Class, today we're going to be factoring some polynomials. This is stuff that we've done before, but let's review it so that we can know it a little bit better. Let's start with the first step that we always do whenever we're factoring, and that is to find the greatest common factor. So looking at this first one right here, let me get a color here, this first one, I need to look at both terms. I've got 18x and a 27, and I want to determine what's the largest factor that they have in common. Well, 18 has factors of 2, 3, 6, and 9. And 27 has factors of, 3, 4, 5, 6, 7, 8, 9. That's it. But the largest one is 9. So I can factor that 9 out. 9, and when I take 18x divided by 9, I get 2x. And then 27 divided by 9 is 3. So the factored form is 9 times 2x plus 3. Now this next one has a little bit different of type of factor that can be factored out. This is one term, and this one is the other term. And notice they both have 2x plus 5 as a factor of those terms. So that is my common factor. So I'm going to factor out a 2x plus 5. What's left is the other factor. It's the 2x plus 5 is being multiplied to the x squared and the 17. So in factored form, it's 2x plus 5 times x squared plus 17. When we factor by grouping, we're going to be using what we just did on the previous example, where we have a factor that's in common. But first we want to find out what that factor is. So we're going to group these first two terms and find the common factor of that. And the common factor is x squared. And it's being multiplied to the 3x minus 2. Then I want to take a look at this factor, or this pair of terms in the polynomial. Negative 6x and 4 have a common factor of negative 2. And when you factor the negative 2 out, you're left with 3x minus 2. So now we have two terms, and they both have 3x minus 2 in common. So that's the greatest common factor, 3x minus 2. And it's being multiplied to the x squared and the negative 2. So 3x minus 2 times x squared minus 2 is the factored form of this polynomial. Once we get into trinomials, there's a method that I prefer. There are a couple other methods too, but this is the one I prefer. It's called the AC method. And we call it the AC method because we're going to really focus on this A and the C. So in this polynomial, x squared plus 2x minus 15, our A is 1 because it's 1x squared, and our B is 2, and our C is negative 15. I want to get this to be in two binomials being factored together. It's like undoing of the FOIL method of distribution. So I'm going to look for what is A times C. So A is 1 times negative 15, and that equals negative 15. And what are the factors of negative 15? So I have negative 1 and 15, negative 3 and 5, negative 5 and 3, and negative 15 and 1. And I want to see which one of these pairs of factors equals the 2 when added together. So negative 3 and 5 add up to 2. So I'm going to rewrite this polynomial with the x squared, but that 2x now is going to become negative 3x plus 5x, because the negative 3 plus 5 equals 2. and then minus 15. Now we're going to factor by grouping. In x squared minus 3x, it has a common factor of x being multiplied to the x minus 3. The 5x minus 15 has a 5 in common, multiplied to x minus 3. So x minus 3 is my common factor, and it's being multiplied to the x and the 5. So my factored form is x minus 3 times x plus 5. Let's try one more trinomial with using that AC method. So this one, A, is going to equal 3, B equals negative 25, and C is equal to 28. So when I do A times C, it's 3 times negative 25, which is negative, I'm sorry, not negative 28, that's B, 28. Okay, let's erase that. All right, so it's going to be 28, and that's going to give us 84, and not negative. All right, so let's look at some factors of 84. Those factors have to add up to B, which is a negative 25. So I know they're both going to be negative. So negative 2 times negative 42, well, that gives us negative 44. Negative 3 goes into it negative 28 times, but when you add that together, you get negative 31. The next one is negative 4 goes into it negative 21 times, and when you add that together, you get negative 25. And I can stop because I found it. So this negative 25x is going to be rewritten as negative 4x minus 21x. And I'm going to put that first term, 3x squared, and the last term, 28. Now I'm going to factor by grouping. So 3x squared minus 4x has a common factor of x, leaving us with 3x minus 4. The negative 21x plus 28 has a common factor of negative 7, leaving us with 3x minus 4. Now that 3x minus 4 is a common factor in these two terms, so 3x minus 4, and that's being multiplied to this x and this negative 7. So in factored form, 3x minus 4 times x minus 7 gives us our answer. So now we're going to look at the difference of squares, and you know what? You're going to see this one a lot of times. You know it's a difference of squares because this first term is a perfect square. The second term is a perfect square, and you're finding the difference of that. Now there is a pattern to this. If I have a term squared minus another term squared, it factors into conjugates of a plus b times a minus b. So a being the square root of a squared and b being the square root of b squared. So what I want to know is what is the square root of 36x squared? Well, that's going to be 6x. And what is the square root of 49? Well, that is 7. So this factors into conjugates of 6x plus 7 times 6x minus 7. You know, I just gave you a pattern for the difference of squares. A squared minus b squared factors into a plus b, a minus b. And you're going to get, coming up is a cubed plus b cubed and a cubed minus b cubed. Those also have some patterns. And you're going to wonder, why didn't she give us a squared plus b squared? How do you factor that one? Well, you can't. This one is prime and cannot be factored. And you will encounter this because it does exist, but if you see this and it tells you to factor it, you can say it's prime or just give us a squared plus b squared. We're going to look at perfect square trinomials, and if you do not recognize this as being a perfect square trinomial, it is okay to use the AC method. It will work. But this, if you can recognize this, it is going to make your life a little simpler. Because if I were to take a plus b and square that, that equals a squared plus 2ab plus b squared. So if I'm to know if this is a perfect square, I'm going to look at what's the square root of this first term, 4x squared. Well, it's 2x. What's the square root of the last term, 25? Well, that square root is 5. Now if I take these and I multiply them together and multiply them by 2, so 2 times 5 times 2 is 20, and we have an x here. If this is 2ab, then that is a perfect square trinomial, and I can set these two as 2x plus 5 and just say squared. And like I said, if you cannot remember this factor, then, or this pattern, go back to the AC method. It will always work. So as promised, here's one of the other patterns. If you have a perfect cubed and you're subtracting a perfect cube, you can factor this into, and this one's a little long, a minus b is the first one, but this next one is a trinomial. It's a squared plus ab plus b squared. So this one, 8x cubed, is a perfect cube because the cube root of that is 2x. So that's our a term. And then we can take the cube root of 27, and that is 3, and that's going to be our b term. So we can factor this into 2x minus 3 times an a squared, so that's the a is 2x, so 2x times 2x is 4x squared, plus ab, so we're going to multiply these together, 2x plus times 3, and we get 6x. And then that last term, b, is squared, giving us 9. And this is the factored form. 2x plus minus 3 times 4x squared plus 6x plus 9. The sum of cubes also has a pattern, and it's very, very similar to the difference of cubes. So if you're given a cubed plus b cubed, you're going to factor that into a plus b times a squared minus ab plus b squared. So let's see if this is, we know it's a sum because it's plus. The cube root of 64x cubed. Well, the cube root of 64 is 4, so 4x. And then the cube root of 125 y cubed is going to give us 5y. So I can fact, since they are perfect cubes, you know, I can find the cube root of them. I'm going to put those, this is my a term, and this is my b term. So I'm going to have a 4x plus b, which is 5y. Then we take that a term and then we square it, so 4x, when we square that, is 16x squared. And then we're going to multiply these two together. 4x times 5y is 20xy. And then our b term squared, so 5y, when we square that, gives us 25y squared. And this is our factored form of the sum of cubes.